Chapter 5, Section 1. 1. Iron sand. Consisting principally of ferruginous sand and sandstone, and containing subordinate strata of ironstone, marl, and clay, with shelly limestone, alternating irregularly, and also beds of wood coal. The iron sand is considered by Mr. Conybeare as the lowest of the formations which intervene between the oolites and the chalk. The sand and sandstone are entirely siliceous, and contain a great portion of brown or yellow oxide of iron, often indeed in such quantity that many of its beds were formerly worked for the purpose of obtaining the ore of that metal. The texture of the sandstones is evidently mechanical, and they often form coarse-grained conglomerates, consisting of quartzose pebbles of various sizes, embedded in a ferrugino-siliceous cement. The forest ridge and a considerable portion of the weald consist of this deposit, which rises from beneath the weald clay and occupies the northeastern division of the county. It forms a range of hills which run in a west-northwest direction from Hastings to near Horsham, having a soil either of sandy loam upon grit stone, or of black vegetable earth upon clay or marl. Its principal elevations have been already mentioned. A great proportion of these hills is but little better than barren sand, of which St. Leonard's and Ashdown forests are computed to contain nearly 30,000 acres. The sterility of this extensive tract is ascribed to the ferruginous impregnation of the soil from the beds of ironstone. On the coast, the ironstone is first seen near Bexhill, rising from beneath the marshland of Pevensey levels, from whence it forms a line of cliffs that extends to Hastings and terminates near Winchelsea. We shall proceed to notice a few localities of this deposit in the southeastern part of the county. At Little Horsted, 5 miles north-northeast from Lewes, the iron sand first appears. It is seen immediately below the turf on the brow of a gentle elevation near the 45th milestone, and forms the hill on which Horsted Church and the seat of Ewan Law, Esquire, are situated. On the east side of the road, the strata appear in the following succession, dipping towards the southwest. 1. Sandstone of a ferruginous color. 2. Grey sand about 6 or 8 inches thick, containing minute fragments of charred wood. 3. Sandy marl 2 feet thick. 4. Sand and sandstone highly ferruginous. 5. White sand and sandstone. On the southern slope of Horsted Hill, the sand is covered by a bed of peat, 6 feet thick, which extends over several fields and is cut for domestic purposes. The wells in the neighborhood are about 60 feet deep and have a constant supply of good water. Proceeding northward, the sandstone presents a bolder outline, and rocks of considerable magnitude protrude through the soil on both sides of the road. The strata are from 3 to 6 feet thick, and are separated from each other by thin layers of soft sandstone shale. Their inclination is towards the southwest, except in a few instances, where a contrary direction is observable. In the immediate vicinity of Uckfield, grey sandstone rocks of low elevation are very numerous. Their summits are rounded and covered for the most part with coppices and underwood, but their sides are bare and exhibit evident traces of diluvian action. Near the Rocks, the seat of Mrs. Jackson, about half a mile west of Uckfield, a group of sandstone rocks occurs, under circumstances of considerable beauty and picturesque effect. The path that leads to this interesting spot lies to the right of the road, and, by a circuitous route, conducts the spectator to the center of a wood, when a beautiful lake, nearly surrounded by rocks, suddenly opens to the view. The cliffs overhanging the water are from 20 to 30 feet high and are surmounted by forest trees and underwood. In some places the rocks are nearly perpendicular. In others they descend with a gentle slope to the water's edge, the declivity being covered by a luxuriant vegetation. On the northern margin, a projecting point of high rock is perforated by a natural archway that has been enlarged by art, and this leads to a recess in the sandstone on a level with the bosom of the lake. From this point, the picturesque beauty of the scene is exhibited to peculiar advantage. On the opposite shore, the base of a rock that juts into the water is in like manner excavated into an arch, beneath which a little shallop was moored at the time of my visit. In one of the vertical cliffs, some fine young birch trees had taken root between the thin layers that separate the strata, and in almost every fissure of the rocks, numerous plants had insinuated themselves, and by the beauty and variety of their foliage relieved the monotonous and sombre appearance of the smooth gray sandstone. On the less elevated masses, lichens, mosses, and heaths were growing in great profusion and luxuriance. The strata are nearly horizontal and partake of the characters of those already described. A fine lake, overhung with sandstone rocks and crested with a noble wood, near the seat of the Earl of Sheffield, in the parish of Fletching, might also be mentioned as affording another example of the picturesque scenery, to which the irregular surface of the sandstone gives rise in certain situations. Here, as in other parts of its course, the soil is in general sterile, but some spots near Fletching are remarkable for flourishing oaks. These contain 6 parts of sand, 1 part of clay, and a considerable proportion of finely divided vegetable matter. 100 parts of this soil, analyzed by Sir Humphrey Davy, gave the following results. Silica, 54 parts. Alumina, 28 parts. Carbonate of lime, 3 parts. Oxide of iron, 5 parts. Decomposing vegetable matter, 4 parts. Moisture and loss, 6 parts. Total 100 parts. Near Longford, in the parish of Barkham, a section is exposed by the road leading from Barkham Cross to Newark Park. At this spot the sand basets out from beneath the wheeled clay, and forms an elevated bank on the north side of the rivulet that flows along the line of junction. The beds of sand and sandstone are here nearly 12 feet high, and agree in their nature and relations with those which occur at Horsted. Insulated portions of sand and sandstone rise to the surface near Isfield paper mill, and also on the opposite bank of the river. But from the quantity of soil and vegetation with which they are surrounded, their extent cannot be determined with any degree of accuracy. On the coast, the cliffs near Hastings expose an interesting section of the iron sand. The strata are less ferruginous than in the localities previously described, and the sand is finer and more loose and friable. It sometimes contains impressions of ferns, charred wood, and the stems of vegetables. At Rye, the sand is highly ferruginous, and the sandstone of coarser texture. It is unnecessary to describe the course of the iron, sand, and sandstone more minutely, as the strata, although distributed over a considerable extent of country, present but little variety and are destitute of organic remains. The localities already noticed are sufficiently characteristic of their usual appearance and structure. We shall therefore pass to the examination of the ironstone, limestone, and coal, since the history of these beds possesses considerable interest in an economical as well as a geological point of view. 1. Ironstone. This substance is internally of a dark steel gray, and generally very hard and compact. Occasionally it is laminated, and separates into thin flakes upon exposure to the air. It occurs either in irregular concretions in the sand, or is stratified and alternates with beds of sandstone. The globular masses often contain nodules of argillaceous earth, round which the ironstone is disposed in concentric layers. In some parts of the county, the ironstone is of excellent quality, and extensive foundries were anciently established in different parts of its course. The almost inexhaustible quantity of wood with which the country was covered in the early centuries, and the numerous lakes and morasses, which the total neglect of drainage had occasioned, being circumstances peculiarly favorable for the conversion of the iron ore into bars. For this purpose the lords of the several manors which lie within the woodland district collected the rivulets into large ponds, and erected mills and furnaces. The iron so procured was at first principally used for agricultural implements. But Fuller also observes in his Worthies that it is almost incredible how many great guns were made of the iron of this county. The total decline of the manufacture in Sussex is to be attributed to the establishments in Scotland and Wales, in which pit coal is used, the superior cheapness of fuel having enabled them to monopolize the trade. There is now but a single foundry in the Eastern Division, and which belongs to the Earl of Ashburnham. According to the present practice, it requires 50 loads of charcoal and 50 loads of ironstone, 12 bushels to each load, to make 13 tons of pig iron. Mr. Young, in his General View of the Agriculture of Sussex, gives the following account of the strata of ironstone in the vicinity of Ashburnham. At Penhurst, near Battle, the soil is gravelly to an indeterminate depth. At the bottom of the Earl of Ashburnham's park, sandstone is found solid enough for building. Advancing up the hill, the sand rock is 21 feet in thickness, but so friable as easily to be reduced to powder. On this immediately a marl sets on, in the different depths of which the ironstone comes on regularly, in all the various kinds as follows. 1. Small balls, provincially 12 foots, because so many feet distant from the first to the last bed. 2. Grey limestone, which is used as a flux. 3. Foxes. 4. Rigget. 5. Balls. 6. Kabbalah balls. 7. Whiteburn, what Tripoli, properly calcined and treated, is made of. 8. Clouts. 9. Pity. Advancing on, there is a valley, where the mineral bed seems entirely broken, and the sandstone sets on. At the distance of something more than a mile, the ironstone is again seen. Another intervention of sand, and then at low water, when the tide goes out, the beds of ironstone appear regularly on the shore. In taking the range northwardly, from the bottom of the Ashburnham Park, for 12 miles at least, the strata are nearly the same, there being no material inequality of surface that does not partake of sandstone, marl, ironstone, and sand again at the top. The limestone and ironstone generally rise very near the surface, frequently within 3 feet. The ironstone, at 40 feet below the surface, is not so good as nearer to it, being coarser, and working heavier in the furnace. The very best of the veins are frequently intersected with stripes, the thickness of a quill, filled with a soft marly matter, and the marl beds which the iron lies in wear a bluer appearance than where it is good. The iron ore, of a dark color and good quality, is very strongly attracted by the magnet. 2. Limestone and shale, in blue clay. The limestone of the iron sand perfectly resembles, both in appearance and composition, the Sussex marble of the Weald, and like that deposit is embedded in a thick stratum of blue clay. In fact, so striking is the resemblance, that but for the remarkable difference observable in their organic remains, the respective strata, in different parts of their course, could scarcely be distinguished from each other. The limestone under examination is of a light bluish-gray, dark blue, yellowish, or reddish-brown color. The upper layers are splintery, and fall to pieces by exposure to the air and moisture. but the lower beds are extremely hard and form slabs, whose superficial measure frequently equals 6 or 7 feet. It is composed almost entirely of bivalve shells embedded in a calcareous cement and is commonly of a subcrystalline structure. The shells chiefly belong to a species of Telina, but they are in too mutilated a state to admit of their characters being correctly determined. This limestone extends from Hastings to near Battle, Ashburnham, Netherfield, Burwash, Rutherfield, and Framfield, and although its outcrop is in many places obscured or altogether concealed by alluvial deposits, yet there can be no doubt of its continuity beneath the surface, along the tract of country here described. On the estate of the Earl of Ashburnham, extensive lime works have long been established, and previously to the present depressed state of agriculture, were carried on upon a very extended scale. These works are in the centre of Archer's Wood, about 2 miles from Battle. The limestone is worked by means of shafts, sunk to the depth of from 90 to 120 feet. The following is the order in which the beds usually occur. 1. Loam of an ochraceous or grayish color, with thin layers of friable shelly limestone. 2. Gray limestone, remarkably firm and compact, composed of bivalve shells, converted into spatose calcareous spar, and held together by a calcareous cement, alternating with gray, marl, and shale. 3. Compact blue shale and limestone, in alternate layers, from 14 to 20 inches thick, and destitute of organic remains. The depth of these beds is indeterminate, but exceeds 50 feet. The strata incline towards the southwest, and dip beneath the iron sand of Ashburnham Park. Mr. Young has given the following measurements of the entire series of limestone and shale, exposed by one of the shafts at Archer's Wood, enumerating them according to their order of succession. Grays 1. The first limestone, 3 feet 3 inches. Shale, 8 feet 0 inches. Second limestone, 0 feet 9 inches. Shale, 9 feet 0 inches. Third limestone, 4 feet 0 inches. Shale, 39 feet 0 inches. Fourth limestone, 1 foot 1 inch. Shale, 3 feet 0 inches. Fifth limestone, 0 feet 8 inches. Shale, 3 feet 0 inches. Sixth limestone, 0 feet 8 inches. Shale, 2 feet 0 inches. Seventh limestone, 8 feet 3 inches. Shale, 4 feet 0 inches. Eighth limestone, 2 feet 0 inches. Shale, 1 feet 6 inches. Ninth limestone, 0 feet 6 inches. Shale, 0 feet 4 inches. 10th limestone, 0 feet 9 inches. Shale, 1 foot 3 inches. 11th limestone, 1 foot 2 inches. Shale, 0 feet 4 inches. 12th limestone, 0 feet 8 inches. Shale, 1 foot 1 inch. 13th limestone, 1 foot 1 inch. Shale, 1 foot 6 inches. 14th limestone, 0 feet 6 inches. Shale, 8 feet 0 inches. 15th limestone, 2 feet 3 inches. Very weak. Oh well, I'll survive. The last stone is fine enough to set a razor. The Sussex limestone upon trial has been found to be superior both to the Maidstone and Plymouth stone, and it is now acknowledged that no cement equal to it in the kingdom has been discovered. It is the received opinion that the limestone ranges 8 miles from east to west and 1 mile from north to south. At Terrible Down, 6.5 miles northeast from Lewes, the iron sand lies beneath a thick alluvial deposit of loam, sand, and marl, interspersed with thin laminae of ironstone shale and rounded fragments of sandstone. These beds extend to Eason's Green, where they are succeeded by a dark blue clay containing shelly limestone, which appears immediately beneath the turf, and is of very considerable thickness. Proceeding northwards, the clay forms a gentle declivity, which is skirted at the bottom by a rivulet. On the opposite side of the stream it swells into a low hill, and terminates in a valley near the 9th milestone. Here the sand and sandstone reappear at the surface, rising from beneath the clay, and gradually uniting with the higher strata of the forest ridge, near the Black Boys. From the absence of natural sections, the relative position of the clay and sandstone is involved in some obscurity, but the former, with its embedded limestone, is so perfectly analogous to that of Ashburnham above described, that there can be no hesitation in considering them as consecutive deposits. The limestone of Framfield, like that of Ashburnham, Rotherfield, etc., is almost wholly composed of a species of Talina. It is exposed to view on the side of the road leading from Lewes to the Black Boys, nearly opposite to the 9th milestone, and is only occasionally quarried. It lies but a few feet beneath the surface, and occurs in horizontal strata, divided into thin slabs by layers of blue clay, that contain laminae of a reddish-brown shale, and shells of the same kind as the limestone. In the section, Figure 2, Tablet 3, these beds are represented as if lying in a basin or hollow of the iron sand, but subsequent observations have convinced me that this position is incorrect and that the limestone forms an intervening deposit. At Isfield, about 6 miles from Lewes, in sinking the well near the paper mill, a layer of bivalve limestone was discovered in a bed of blue clay at the depth of 90 feet. It evidently belongs to the same deposit as that of Framfield, but the shells appear to be of a different species. Mr. Wood, author of General Conchology, etc., considers them as nearly related to Telina cornea, if indeed they are not of the same species. The geological position of these argillaceous limestone strata is involved in some obscurity. The lowermost beds at Ashburnham are supposed by an eminent geologist to coincide with those of the Purbeck limestone. But at the same time he remarks that until they shall have been more scientifically observed, it is impossible to speak with absolute certainty. In the present imperfect state of our knowledge, it may indeed be disputed whether these beds alternate with the Ferengious sand, as represented in Figure 3, Tablet 3, are situated in a hollow or basin of that deposit, as in Figures 1 and 2, Tablet 3, or form a protrusion or hillock of the Purbeck limestone, as in the annexed diagram. Section 3. Coal. At Newark Park, Waldron, and Bexel, seams of fibrous coal resembling that of Bovey have been discovered, but the thickness and extent of the beds have not been correctly ascertained. To Mr. Cater Rand of Lewes I am indebted for the following section of the strata at Newark. Section of the strata in Newark Old Park, situated 1 mile from the banks of the Lewes Canal. 1. Vegetable earth and sand. 2. Sandstone and clay. 3. Sandstone and indurated marl. 4. Shivery sandstone and clay. 5. Indurated clay rubble. 6. Sandstone and blue clay alternating. 7. Strong bind. 8. Coal of the Bovey kind, examined only to the depth of 11 inches. It bassets out on the side of a rivulet, and may also be observed in the bank of the adjoining hop grounds. Several bushels of coal were dug up. The strata have a slight inclination west-northwest. The Newark coal in my possession has very much the character of jet. It is of a velvet black, does not soil the fingers, has a resinous luster, and a conchoidal fracture, is very brittle, and burns with a bright flame. At Bexel, the southeastern extremity of the forest ridge towards the sea, indications of coal induced some enterprising individuals to sink a shaft, and at the depth of 160 feet, a bed of coal of good quality was discovered. But unfortunately the works were suddenly inundated by a vast body of water, and the undertaking was finally abandoned. It appears that the enterprise originated from the suggestions of a Mr. James, who was sent to Bexel in 1804 to survey the estates of the Duke of Dorset. This gentleman, perceiving some resemblance between the strata exposed by the wells at Bexel Barracks and those which occur at Bovey, imagined that a bed of coal might be found at the depth of about 60 yards. In consequence of this idea, a company of adventurers was soon formed, and the requisite operations were carried on in a close near the seashore. I have to offer my acknowledgments to Mr. Rand for the following account of the beds passed through on that occasion. Section of strata at Bexel, explored in a search for coal in 1804 to 1809. Sunk, soil, clay, and sandy loam, 3 yards. Dark clunch, 3 yards. White rock with kind partings, 3 yards. Bored, soil, clay, and sandy loam, 1 yard 1 foot. Dark clunch, 1 foot. Gray rock, Dark clunch, 1 yard. Gray rock, 1 yard 2 feet. Dark clunch, 1 yard. Strong gray rock, 1 yard 2 feet 6 inches. Blue binds, 1 yard 6 inches. Gray rock with kind partings, 6 yards. Blue bind, 1 yard 6 inches. Stone gray rock, 1 yard. Blue bind, 2 feet 7 inches. Strong white rock, 1 yard 1 foot 4 inches. Dark clunch, 2 yards 1 foot 9 inches. Smut coal, 2 feet 3 inches. Gray bind, 4 yards 2 feet 3 inches. Blue bind with iron ore, 3 yards 1 foot 9 inches. White stone, 1 yard. Clunch or fire clay, 1 yard 2 inches. White sandstone, 1 yard 2 feet 9 inches. Kind clunch parting, 8 inches. Brown sandy rock, 2 feet 9 inches. Sharp peldron, 3 yards. Blue bind, 1 yard 2 feet. Strong brown rock, 1 yard 1 foot. Blue bind containing impressions of fern leaves, 2 yards 1 foot 6 inches. Blue bind with iron ore, 2 feet. Strong coal, 1 yard 6 inches. Total yards, 54. Total, 54 yards 1 foot 9 inches. The borings were continued, but no account remains of the nature or depth of the strata. Mention is made of a second bed of coal 4 feet 6 inches thick, the coal of bad quality, and very sulphurous. Salt water oozed through the divisions of the beds, and although an engine of 80 horsepower was employed, the works were completely inundated. I have not seen any specimens of the Bexel coal, but according to Mr. Rand, it resembled that of Newark. It is not a little curious that research for coal is so improbable a situation. It is not a little curious that research for coal in so improbable a situation should have been attended with the slightest indication of such a substance, since if in the present infancy of geological science we may venture to draw any general conclusions from established facts, there was every reason to suppose that such an attempt must have proved abortive. At Waldron, a thin bed of cannel coal has been noticed on the banks of a rivulet which separates that parish from Heathfield, but it has not been examined with any degree of attention. It is stated to occur in beds of a few inches thick, that extend for 1/4 of a mile immediately beneath the surface, at the bottom of Gear's Wood. Organic remains. The organic remains discovered in the strata above described are few and unimportant. The bivalves of the limestone, the impressions of ferns in the sandstone of Bexhill and Hastings, and the fragments of lignite in that of Horsted, being the only extraneous fossils that have been observed. In other parts of England, the iron sand contains notuli, ammonites, belmanites, austriae, terebratulae, and numerous varieties of spongitae, and other zoophytes, but of these no traces exist in the sand of Sussex. Embedded in a Ferrugino-siliceous cement. Extracted from a memoir on the iron sand by the Reverend W. D. Conybeare, F.R.S., published in the new edition of Phillips' Outlines of Geology, 1822. This interesting little volume is certainly one of the most valuable works on geology that has appeared in this or any other country. It contains a complete epitome of all that is at present known concerning the geological structure of the British Islands, and abounds with the most useful information. And in almost every fissure of the rocks numerous plants. Among others I noticed Osmunda regalis, Anterinum cymbalaria, Polypodium vulgaris, Polypodium felix mas, Lichen rangiferinus, Erica vulgarius, etc. "100 parts of this soil analyzed by Sir Humphrey Davy. Davy's Elements of Agricultural Chemistry, 4 volumes. To make 13 tons of pig iron. Dalloway's History of the Western Division of the County of Sussex, Volume 1, page 161, folio 1815. Small balls. The provincial terms employed by Mr. Young are now obsolete. At least I was unable to obtain any explanation of them from the workmen on a recent visit to Ashburnham. The iron ore of a dark color and good quality is very strongly attracted by the magnet. Young's Agricultural Survey, 8 volumes, 1808. "1 mile from north to south, Young's Agricultural Survey. Eason's Green. Vid. Table 3, figures 2 and 3. It is almost wholly composed of a species of Telina. Mr. G. B. Sowerby, author of the Genera of Recent and Fossil Shells, kindly obliged me by an examination of the shells contained in the Framfield limestone. The general appearance of some of the specimens he thought resembled the nucleae, but other circumstances led him to consider it probable that they might belong to the genus Sirene. The important question whether they are of marine or of freshwater origin is therefore still undecided. An eminent geologist, Reverend W. Conybeare, in Phillips' Geological Outlines, etc. Other zoophytes. Phillips' Outlines, page 140.